In the last two videos, I walked you through a couple of simple scenarios using JPQL to retrieve targeted information from the music database. In this video, I'll do something similar, but I'll use the Criteria Builder. The Criteria Builder interface describes a factory class for creating various type-safe query components. It provides methods for creating the different parts of a JPA query, each described as an object and not just part of a string. The Criteria Builder's methods are used to create specific instances, both the criteria query object and its parts, the specific criteria, in other words, that make up the definition of the query. A query in its simplest form consists of a command as well as a source of some sort. A command might be select, update, or delete, and a source in SQL is usually a table or view, whereas in JPQL it's an entity. A query may also have many other clauses and specifics which define what needs to be done. The Criteria Builder provides all the building blocks as Java objects to fashion a specific query. It starts with the criteria query instance. You can think of this as the scaffolding in which everything else is going to be placed. The scaffolding has specific slots, and these translate to methods on the criteria query. The building blocks fall into one of four categories, which include the predicate, expression, selection, and order types. The Criteria Builder isn't responsible for executing a query or even putting all the parts together. It is just responsible for creating customizable components you'll need. The criteria query object will use the building block types in its design to construct a specific query. The criteria query is a bit like scaffolding and a bit similar to a string builder object in that things get added and the instance mutates and grows. Unlike the string builder though, the additions to the criteria query object can be of multiple types depending on the method selected. Pause the video here for just a moment and take a little time to familiarize yourself with some of the methods on this class. You'll notice that the methods on this class almost all represent specific clauses or expressions in a select query. You've got the select method, the from method, a where method, as well as others like distinct, order by, having, group by, and so on, which should be familiar terms for anyone who has written SQL queries. Also notice the arguments passed to these methods, which mostly consist of the four types I mentioned already, and which are displayed here as well. When you pass instances of these types to methods, you'll be using a Criteria Builder factory method to get specific instances of these types. A predicate represents a condition in a where clause. An expression represents a computed value. This can be a mathematical expression, a function call, or a field reference. An order is used to represent sorting criteria for the order by clause. A selection represents an attribute, expression, or result used to define the selectable output of the query. Finally, notice the from method on this class. This method is different from the rest and returns a root instance. The root is a special type and it's the bridge between the criteria query and your entity. It's the source of the query's data. It's more common to have just one root, but there's support for multiples. I also want you to see that other than the from method, all of these methods return an instance of criteria query. Like the string builder object, the criteria query object is mutable, but each method returns a reference to itself. This means you can optionally chain these methods together, which provides the advantage of more concise and readable code. This slide summarizes how to use the Criteria Builder and criteria query types to execute queries using JPA entities. First, you get an instance of Criteria Builder using the getCriteriaBuilder method on an entity manager. Once you have a Criteria Builder, you then get a criteria query instance from that. You'll specify the root or entity that the query will select its data from. You then specify additional information or the details about the query, like a where clause, an order by, or group by clause, for example. You'll invoke various methods on criteria query while using the Criteria Builder to manufacture the appropriate pieces which get passed as arguments. Once you've constructed the query's criteria, you create an executable query like we did with the JPQL typed query by calling createQuery on the entity manager. This method returns a query instance which is different from the criteria query instance. You execute the query and retrieve results using one of the several methods on the query instance. You'll remember these include getResultList, getResultStream, and getSingleResult, for example. Now that you've got a basic understanding of what this process consists of, let's work through it in some code. Getting back to my JPA project and the main query class, I'll add another private static method. This time I'll return a stream of artist instances. I'll call this method getArtistsBuilder, and its parameters will be the same as the earlier method. So an entity manager first, and then a string I'll again call matchedValue. I start by creating a criteria builder variable, which I'll call builder. I get an instance of a criteria builder from entity manager using the method getCriteriaBuilder. Next I'll set up a criteria query variable with a type argument of artist. I use the criteria builder method createQuery to get an instance, and I pass that the artist class. Next I need something called a query root. This represents the starting point for constructing a query against a dataset represented as an entity class. So this has the root type with artist as the type argument. I'll just call it root, and I can get this using criteria query.from and passing artist.class to that method. You can think of the root as the from clause in JPQL. So if I add nothing to the root, the entire table associated with this entity is the dataset that will be operated on. Next I define the operation I want to execute on my criteria query object, which in this case is select. I pass it the root instance. Finally, I can create the query and call getResultStream. Now moving back up to the main method, I'll insert the next segment of code before the commented out code that's currently in the try block. I'll include a separator line so I can distinguish the output from the earlier method call. I'll include a stream of artists, setting that to the value I get back from my new method, getArtistsBuilder. I'll pass that the entity manager variable, and for now, an empty string literal. Because I get a stream back, I can use stream operations to manipulate the data further. I'm going to limit the results to 10. A more refined query would have brought less data back, which is a much better approach. I'm really just including it here now, so I don't have to look at 200 lines of output. Next, I'll collect the data into a map using collectors.toMap. The first argument specifies the function to get the key, so it's keyed by the artist name. The next argument is the function to get the value, so that's just the number of albums. Next, I need to specify a merge function, and I'll just use the method reference for integer sum there. I want a tree map back because it'll be ordered. Finally, I want to print the artist name and the number of albums that artist has in the data. I've no idea what happened with the formatting. Let me reformat the code. For some reason, TreeMap did not get imported. I'll add it manually. That fixed it. I will run this code. And now you see 10 artists in artist name order and the number of albums each of these has. This just printed the first 10 artists it got because of the limit operation. The artists weren't ordered in the stream, though they're ordered here. I'll next refine the query to include an order by clause, so I'll go back to the getArtistsBuilder method. I start with criteria query and call order by passing another factory object, which I get by calling a method ASC, which stands for ascending order. This method returns an order instance. I pass root, get artist name in there, which defines how to sort. I'll rerun my code. I've got a different set of artists, so the first 10 alphabetically, starting with 1000 Maniacs. I'm really still getting all 200 back, so I'll next include a where clause. Getting back to my getArtistsBuilder method, I'll insert another statement between the where method and the order by method. These don't really have to be in this order, but I'll just keep them in the logical order of a SQL statement. I start by invoking the where method on criteria query. I need to pass that a predicate instance, which I can get from many methods on the criteria builder, but in this case I want to use the like method, passing that root, get artist name, and the matched value. Next I'll scroll back up to the main method, where I'll next change the empty string literal. replacing that with the text BL%. This means I want to get only artists whose names start with BL. I run this. I get matching records, so my where clause worked, and I'm only getting artists whose names start with BL. Before I move on, I'll just change the getArtistsBuilder method one last time. The criteria query is a mutable object, which is why I don't need to reassign the instance on each of these method calls. Each method outputs a reference to itself, which means I can chain methods together, so I'll do that. This creates a chain of 3 methods. I'll use IntelliJ to reformat this code. You can see this reads somewhat like stream operations. This is a lot easier to read in my opinion. I'll run that and confirm I get the same results as before. And I do. In the interest of time, I won't be covering how to do joins in a criteria builder query here, because I want to quickly show you how to execute a native query. Again, I'm not applying the same standard to teaching you JPA as I have been Java's core functionality. This foray into JPA was a bit of a courtesy, since it's increasingly becoming an industry standard in some form or another. If you're curious about joins, be sure to see the bonus section of the challenge that follows. Finally, I'll quickly demonstrate one last way to query using JPA, and that's by executing a native query with the Entity Manager. I'll add another method. This is private static, returns a stream of artist, and it'll be called getArtistsSQL. This method will have the same parameters as the others, so an Entity Manager and a string named matchedValue. I'll set up a local variable called query, the result of calling createNativeQuery on the Entity Manager argument. This method takes a string, which is native SQL, but with one minor exception. This string can contain placeholders, either named or numeric, which I'll use here. I'll select from the table, and just to make it clearer, I'll include the schema, so select star from music.artists where artist has a name, and this is the column name now, not the entity name, like $1. I still pass the artist class as the second argument, because the JPA provider will instantiate artist instances from the data through JPA Magic. I also still set the parameter, and that's parameter 1, that'll get set to the matched value. Finally, I'll return the results as a stream. Going back up to my main method, I'll change the code. That was calling getArtistsBuilder, and replace it with a call to this method, so getArtistsSQL. I'll run that, and you can see that again produces the same result as the criteria builder code when it didn't include the order by clause. Which type of query you use is dependent on a lot of different factors. This slide summarizes the 3 types of queries you can execute using JPA. The native query executes native SQL queries directly. This gives you full control over SQL syntax. It allows for performance optimizations for specific databases and gives you access to vendor-specific features. The criteria builder query lets you build queries programmatically using Java objects. It's type safe, includes compiled time checking, and allows for dynamic query construction. The JPQL query uses a SQL-like syntax, which is tailored to JPA entities. It's portable across JPA implementations. As you saw, it hides database implementation details and is a more intuitive method for anyone with SQL experience. Okay, so this video ends the introduction to JPA and is the end of the database section of the course. In the next video, I've got a JPA challenge for you. Keep this project open. Your challenge will use the entities and configuration that already exist in this project. I'll see you in that next video.